Hello everyone. Today I am starting a new series in my YouTube channel. I am going to doing a practice video which I will explain each and every module in which you will get a full preparation for your AWS machine learning associate certification examination. So, in this video, I am going to start with machine learning, MLOps, and model evaluation on AWS. In this presentation, I will explain the foundational concepts of machine learning and MLOps on AWS. I will cover what machine learning is, how it relates to AI and deep learning, the major types of machine learning, how the ML lifecycle works, which AWS services supports ML workflows, and how models are evaluated using different matrices. What is machine learning? So, machine learning is a method where systems learn from data. Instead of writing rules for every possible situation, we train a model using examples. This model identifies patterns in the data and uses those patterns to make predictions. For example, a model can predict whether a transaction is fraudulent, whether a customer may leave a service, or what product a user might like. The quality of the model depends heavily on the quality of the data, the features used, the algorithm selected, and how well the model is evaluated. Now, I'm going to learn AI versus machine learning versus deep learning. Like, what is the basic difference between these three? First, let's start with artificial intelligence. Artificial intelligence is the broadest concept. It refers to machines performing tasks that normally requires human intelligence. Machine learning is a part of AI where the system learns from the data. Deep learning is more advanced part of machine learning that uses neural networks with many layers. Deep learning is especially useful for complex tasks such as image recognition, speech recognition, and natural language processing. Now, there are three main types of machine learning. First is the supervised learning. It is when a machine learning model learns from data that already has the correct answer. It studies examples of inputs, outputs, so it can make prediction later. Let me give one example. For example, it can learn from emails labeled spam or not spam, and then predict whether a new email is spam. Unsupervised learning is when the model works with data that does not have labels or correct answers. Instead, it looks for the patterns, similarities, or group on its own. For example, it can group customers based on their shopping behavior. Then comes the reinforcement learning. Reinforcement learning is when a model learns by trying actions and receiving rewards or penalties. It improves over time by learning which actions leads to better results. For example, a robot can learn how to move by being rewarded when it completes a task successfully. Then is the machine learning life cycle. A complete machine learning workflow is the step-by-step process used to build, test, deploy, and maintain a machine learning model. First is the problem definition. It identifies the business goals and decides what the model should predict or classify. For example, a company may want to predict customer churn or classify emails as spam. Second is the data collection. So, in data collection, it gathers the information needed for the model from sources such as databases, files, APIs, logs, or real-time streams. Then comes the data preparation. Data preparation cleans the data by fixing missing values, removing duplicates, correcting errors, and making the data consistent. After that, feature engineering. Feature engineering transforms raw data into useful inputs that help the model learn patterns more effectively. Sixth is the model training. In model training, an algorithm learns from the prepared data to make predictions or classifications. Once trained, the model is tested during model evaluation using matrices such as accuracy, precision, recall, F1 score, or error rate to see how well it performs. If the model performs well, it moves to deployment, where it becomes available for real-world predictions such as through an app, website, or API. Finally, monitoring and retraining. It assures the model continues to work well over time by tracking performance, detecting data drift or errors, and updating the model when needed. Then is the MLOps on AWS. So, it is the practice of managing machine learning models in a structured, automated, and reliable way. It combines machine learning, DevOps, automation, and monitoring to help them build, deploy, and maintain ML models more efficiently. The main goal of MLOps is to make ML workflow repeatable and reliable. Instead of manually preparing data, training models, testing them, and deploying them, MLOps help automate these steps. It also helps teams track experiments and model versions so they know which model was trained, what data was used, and how well it performed. This is important when comparing models or rolling back to the older version. After deployment, MLOps focuses on monitoring the model. Teams watch for changes in model performance, error, and data drift, which happens when new data becomes different from the data the model was trained on. MLOps also improves collaboration between data engineers, machine learning engineers, and operation teams by giving them shared tools, processes, and pipelines. In AWS, common services used for MLOps includes Amazon SageMaker for building and training the models, SageMaker pipelines for automating workflow, SageMaker Model Registry for tracking model versions, AWS S3 for storing data and models, AWS Glue for data preparation, AWS CloudWatch for monitoring, and AWS Step Function or AWS Lambda for automation. AWS services used in machine learning. First is Amazon SageMaker. It is used to build, train, tune, deploy, and monitor machine learning models. It provides tools for a full machine learning lifecycle. Second is the Amazon S3. It stores important ML files such as datasets, training data, model artifacts, and output results. AWS Glue is used for ETL, data cataloging, and data preparation. It helps clean, organize, and transform data before it is used for training. Fourth is the Amazon Athena. It allows users to query data stored in Amazon S3 using SQL without needing to move the data into a separate database. Then is the Amazon CloudWatch. It collects logs, matrices, alarms, and monitoring data. It helps track system health, model performance, and errors. Sixth is the Amazon Lambda. It runs serverless code for automation. It can trigger tasks automatically when events happen, such as a new file being uploaded to S3. Last is the AWS step functions. It coordinates multi-step workflows. In ML, it can connect tasks like data preparation, training, evaluation, approval, and deployment in one automated process. Then is the classification, regression, and clustering. So let's learn what these three terms are. First, classification. Classification is used when models predict a category or class. The output is discrete, meaning it belongs to a specific group. Example include detecting whether an email is spam or not, identifying fraud, or predicting whether a patient has a disease. Then is the regression. It is used when the model predicts a continuous numerical value. The output is a number. Example including predicting house price, forecasting sales, or estimating temperature. Then is the clustering. It is used to group similar data points together. It does not need labeled data, so the model finds patterns on its own. Examples includes customer segmentation, grouping user behaviors, and discovering unusual patterns or anomalies. Then is the model evaluation matrices. Model evaluation helps determine whether a model is useful. For classification, accuracy gives the overall correctness, but it can be misleading when the data is imbalanced. Precision tells us how many predicted positives were correct. Recall tells us how many actual positives the model found. F1 score balances precision and recall. For regression, we use error-based matrices like MAE, MSE, and RMSE to measure how far predictions are from actual values. To summarize, machine learning uses data to learn patterns and predictions. MLOps helps manage ML system in a reliable automated way. AWS provides services for data storage, preparation, training, deployment, and monitoring. And a major part of building ML solution is choosing the right evaluation matrices and the right interface method based on the business need. So this was all for my today's video. Thank you so much for watching.